Numbers, session 22.
In this session, we are going to see the theorem of de Moivres, and we are going to see how to prove that de Moivres theorem. What is de Moivres theorem? De Moivres theorem says cos theta plus I sin theta the whole power n is equal to cos n theta plus I sin n theta. Very simple formula. Whether we have to find cos theta plus I sin theta the whole power 10 or whole power 11, whatever it may be, de Moivre states it is very simple, no need of worrying. Simply you can apply this formula, that whole power number can be replaced along with the angle, like that it states. So de Moivre's theorem is nothing but cos theta plus I sin theta the whole power n is equal to cos n theta plus I sin n theta. How to prove this? Right. First case, this n may be a positive integer, or it may be a negative integer, or it may be a rational number, or it may be an irrational number. Finally, in total, it may be a real number. But we are going to see only three things, that is positive integer, negative integer, and rational number cases only. Right. How to prove this? To prove this, we have two ideas. One thing we can prove using mathematical induction method, but we are not going to use that method, but we are going to follow a small simple technique. Right. Let us consider n complex numbers which are in polar form. Let the first one be cos theta plus I sin theta 1. Let the second one be cos theta 2 plus I sin theta 2, and it goes on up to cos theta n plus I sin theta n. We have to multiply all these complex numbers. How to multiply all these complex numbers? You know, from the derivation of multiplication of two complex numbers in polar form, what it says, just we have to multiply the modulus and then we have to add the argument, that is angles. So to multiply two complex numbers in polar form, the method says modulus should be multiplied and argument should be added. So to multiply all these complex numbers which are in polar form, there is no need of multiplying this with this like that. Simply we have to multiply their modulus, but here all are having the modulus as 1. Nothing is before this brackets. So there is no need of worrying about modulus. So just we have to think about the arguments. Arguments means angle. For this complex number, first complex number, the argument is theta 1 or the angle is theta 1. For the second complex number, the angle is theta 2. Like that it goes on up to theta n. So the property says to multiply any number of complex numbers, just you have to add their arguments. So according to this rule, we are going to add all the arguments or angles. In case if you have doubt, you can refer session 20, complex numbers, session 20, multiplication and division of complex numbers in polar form derivation video. Right, now we are going to multiply these complex numbers. According to the rule, we have to add the angles. So it becomes cos of theta 1 plus theta 2 plus theta 3, and it goes up to theta n. The same way I sin of. Right. So now we have multiplied all these complex numbers. Right. Now let us consider a small technique. We have to prove only cos theta plus I sin theta the whole power n, but we have so many angles. So what we are going to do is, just let us consider theta 1 is equal to theta 2 is equal to theta 3 is equal to dot 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 up to theta n as theta. We are going to consider these are all equal to one another, and let us consider that value as equal to theta. If we replace theta 1, theta 2, theta 3 and up to theta n by theta, then it will become like this: cos theta plus I sin theta. Again, the next one is also cos theta plus I sin theta. This is also cos theta plus I sin theta. This cos theta n plus I sin theta n is also cos theta plus I sin theta. So if we consider there are n terms like this, right? This is our left hand side, right? Now, in the same way, let us replace the right hand side also with theta. Instead of theta 1, theta 2, up to theta n, we are going to replace everything by theta. So here also there are n terms from this to this, right? So let us try to simplify this. So the left side is n terms, that is a into a into a up to n terms like that, that is a power n. So it becomes cos theta plus I sin theta. We are multiplying it n times, so it becomes cos theta plus I sin theta the whole power n. Here 1 theta plus 1 more theta, 1 more theta, like that we have to add up to n thetas, so it becomes n theta. So here if we add all these things, we'll get n theta. So it becomes cos n theta plus I sin n theta, right? So we have proved our first part. In that first part, we have considered that n as simply a positive integer, right? And we have proved cos theta plus I sin theta the whole power n is equal to cos n theta plus I sin n theta. So this formula is now valid for a positive integer. Now let us try to prove this for negative integer also, right? So in our second case, we are going to prove this for negative integer. Anyhow, already we have proved cos theta plus I sin theta the whole power n is equal to cos n theta plus I sin n theta for a positive integer, right? Now let us consider this n as minus m. Let us consider this n value as minus m. So for this n, we are going to replace this n by a negative integer. So now n becomes a negative value, right? So cos theta plus I sin theta the whole power n, we are going to treat n as minus m. So cos theta plus I sin theta the whole power minus m, right? So now surely it's a power with negative value. It will not change because we have considered m as a positive integer. Since m is positive integer and minus is included, it becomes minus m is a negative integer. So now cos theta plus I sin theta is having a power of negative number, that is negative integer, right? How to proceed? Let us not proceed with negative integer because already we have proof with positive integer. So let us try to make this as positive integer, right? According to that formula, a power minus m can be written as 1 by a power m. So we have done that. 1 by this cos theta plus I sin theta the whole power m minus m becomes plus m, right? Now this m is a positive integer. M is a positive integer. So we can apply this formula because cos theta plus I sin theta the whole power n is equal to cos n theta plus I sin n theta. We have proved for a positive integer. Since this is a positive integer, now we can apply this formula. So we can make this as 1 by cos m theta plus I sin m theta. As this states, this power can enter inside like this. So we have made it, right? But this is quite okay, but we should not have any I in the denominator. For that, we have to multiply the numerator and denominator by its conjugate. So we are going to multiply the numerator and denominator by its conjugate. The conjugate of cos m theta plus I sin m theta is nothing but cos m theta minus I sin m theta, right? 1 into this, we'll get the same answer. This is complex. This is its conjugate. So while we are multiplying a complex number with its conjugate, just we have to do real part square plus imaginary part square. So let us try to do it. So our answer is cos m theta minus I sin m theta. That is numerator into this. For the denominator, we have applied that logic. So you know this value is cos square theta plus sine square theta value is 1. So it will become as 1. So now till this we have proved cos theta plus I sin theta the whole power n is equal to cos m theta minus I sin m theta divided by cos m theta the whole square plus sine m theta the whole square. Right. So let us proceed with that. As I told you, formula for this cos square theta plus sine square theta is 1. So if you apply this value 1, we'll get the answer as cos m theta minus I sin m theta. Right, that's good. Now, let us do some small adjustments because in our proof, we need only positive symbol here. We don't want any negative symbol here. So let us try to do one thing. For cos theta as well as for sine theta, we have two formulae with negative angles. That is, cos of minus theta is equal to cos theta. Right. So we can use this formula. And also one more formula, that is sine of minus theta is equal to minus sine theta. This also we can follow. Why we are following this? Because actually we want a positive sign here to get the proof. So we are trying to do one thing. Is there any way to replace this minus by plus? Yes. Formula says if it is minus sine theta, you can write that as sine of minus theta. So we can write this minus sine m theta as sine of minus m theta. So it will become as a positive one. Right. Moreover, in the polar form, cos part and sine part must have same angle. So if we replace this by minus m theta according to the formula, if we make this as minus m theta, then this should be also minus m theta. Shall we do it? Yes, we can do it because a cos of minus theta is nothing but cos theta. Even if I add a minus sign here, it will not do any harm because formula says cos theta as well as cos of minus theta are equal to one another. So cos m theta can be replaced as cos of minus m theta. So using these techniques, we have applied this 2 in this formula. Instead of m theta, we have written minus m theta. That is no problem because cos of minus theta is cos theta. So quite okay. Here for minus sine theta, according to the formula, we can apply this formula, that is sine of minus theta. So this minus sine m theta can be written as plus I sine of minus theta. Now it is in the exact way, correct way. Am I correct? Cos in minus m theta. Sine is also in minus m theta. Both are of same angle. Here we have positive sign. So it's in the exact polar form. We know this minus m is nothing but n, because while we are proving this second case, we treated this n as negative number. That negative number is treated as minus m. So this minus m is nothing but n. Now let us replace this minus m by n. So cos n theta plus I sin n theta. So now we have proved cos theta plus I sin theta the whole power n is equal to cos n theta plus I sin n theta. First case we have proved this for positive integer. Now we have proved this for negative integer also. Now let us try to prove for rational numbers. Right. Here we are considering n as a rational number. That is, n is equal to p by q, where q is not equal to 0. In this case, we are going to follow a small technique. Just listen. Here, cos theta by q plus I sin theta by q, the whole power q is here. As I told you, n is equal to p by q is a rational number. So this p is an integer and q is also some integer. So totally q is an integer. So according to the first case and the second case, if this power is an integer, we can bring it inside. Because cos theta plus I sin theta the whole power n is equal to cos n theta plus I sin n theta. We proved it for positive integer as well as for negative integer. So q is an integer now, so we can bring it inside. In case if q comes here, automatically q and q will get cancelled. So the final answer will be simply cos theta plus I sin theta. So we can write cos theta by q plus I sin theta by q the whole power q as cos theta plus I sin theta. Right. Now we are going to do a technique such a way. Let us try to bring power p by q in this side, this right side. So for that, let us do a small work. First, let us remove this power q by taking qth power. Actually, our main idea is to bring cos theta plus I sin theta the whole power p by q. Here p is in power and q is in the root. So first we are going to do one thing. First we are going to take qth root on both sides. So let us take qth root on both sides. If we take qth root on both sides, it will be like this. Right. So, there is a formula, that is a power m the whole power n is equal to a power m into n. According to this formula, let us apply this formula here. It is in the form a power m the whole power n. The formula says that 2 should be multiplied. The power should be multiplied. So if we multiply q into 1 by q, q and q will get cancelled. Our answer will be power 1. So the next step, it will become like cos theta by q plus I sin theta by q is equal to cos theta plus I sin theta the whole power 1 by q. Now let us try to take power p on both sides. As I told you, our main goal is to bring the power as p by q. P is power and q is root. First we have taken this qth root on both sides. Now let us try to take power p on both sides. Right, taking power p on both sides. Then it will become like this: cos theta by q plus I sin theta by q the whole power p. Here cos theta plus I sin theta the whole power 1 by q the whole power p. Again, if we apply the same formula, the power should be multiplied. Right. Moreover, this p is an integer. So we can bring this inside, because according to case 1 and case 2, if it is in the form cos theta plus I sin theta the whole power n, we can make it as cos n theta plus I sin n theta. Right. Since the power is an integer, we can bring it inside. So if we apply De Moivre's theorem to this left hand side using case 1, it will become cos of p by q theta plus I sin p by q theta. Power p can be brought inside because p is an integer. Here, according to this rule, we are multiplying these two. Our answer is p by q. We know p by q value is nothing but n. So let us replace this p by q by n. We'll get the answer cos theta plus I sin theta the whole power n. If we replace this p by q by n, it will become cos n theta plus I sin n theta. So we have proved cos theta plus I sin theta the whole power n is equal to cos n theta plus I sin n theta. So we have proved for 3 cases: for positive integer, for negative integer and for rational number. But it is true even for irrational number. But we are not going to prove this here. So we have proved cos theta plus I sin theta the whole power n is equal to cos n theta plus I sin n theta. Right. Using this formula, we can see some corollaries. We can apply this formula also. This is the first formula we have proved now. Cos theta plus I sin theta the whole power n is equal to cos n theta plus I sin n theta. Now, let us think this n as minus n simply. So, as I told you already, whether the power is positive integer or negative integer or a rational number, it's not a matter. We can bring it inside. So if we bring it here, it will become cos of minus n theta. It will become I sin of minus n theta. As I told you, sin of minus theta can be written as minus sin theta. Sin of minus theta can be written as sin of minus theta can be written as minus sin theta. So according to this formula, if minus n comes this side, it will become sin of minus n theta. Sin of minus n theta is nothing but minus sin n theta. So this is next formula. And the third one, instead of cos theta plus I sin theta, if we keep that as cos theta minus I sin theta the whole power n, then the formula will be like this. Again, for this cos theta minus I sin theta the whole power minus n, we have this formula. We can follow a shortcut here to do this very easily. Just multiply this power sign with the middle sign. Plus into plus, plus. Then this middle will be plus I. Minus into plus is minus I. That is minus I. Here plus into minus is minus. You can write minus. Here minus into minus plus, we can write plus. So while we are applying this de Moivre's theorem, just multiply the sign of power with this middle term sign. And you can put it in the middle. Just bring inside only the value of the power. Then it will be very, very easy. If it is power 5, just bring 5 inside. If it is power minus 5 also, just bring 5 inside, but multiply this with this. That is plus into minus is minus. For example, let us consider this problem. For example, if this is cos theta minus I sin theta whole power minus 10. Don't bring minus 10 inside. Just try to bring only 10 inside to the angle. Before that, multiply this symbol. Minus into minus plus. So in the middle, you put plus I. Then just bring this 10. That is cos 10 theta plus I sin 10 theta. Like that we easily do these problems. I hope so you have understood this de Moivre's theorem. Keep it in mind and let us try to do problems in the next session. Thank you.